Good morning. Welcome to this session on aim, scope, and history of taxonomy. I am Shobha Rani, Assistant Professor of Botany, Government First Grade College, Chikbalapur. In this video, I shall be discussing about the aims, objectives, and scope of taxonomy, and briefly about history of taxonomy. Taxonomy is the practice and science of classification. It is derived from the Greek language taxis, meaning order or arrangement, and nomos, law or science. The word taxonomy was first used by great botanist A.P.D. Kandoi. Plant taxonomy can be defined as that branch of biology which deals with description, identification, classification, and naming of plants according to their resemblances and differences. Now, if we look into the scope of taxonomy, it indicates the phylogenetic relationship between species and its ancestry. That is, taxonomy has its relevance in establishing the phylogenetic relationship that exists naturally between many groups of plants. It organizes all the information of plants in an orderly fashion. Using nomenclature principles and rules, all plants are named. It gives a detailed overview of various morphological and anatomical structures of plant species. Plant taxonomy enables to identify any unknown species and its place in classification by comparing with known species. Analyzing of genetic constituents can be done on the basis of systematics. It is used to scientifically name any species, which helps in the uniformity of the name around the world and avoids confusion. It helps to understand the biodiversity present at the place. It also helps in recording all the living species known until now. To study ecology, the knowledge of taxonomy is essential. Plant ecologists must be aware of names of the plants and their relationship to the habitat and environment. So taxonomy is widely used even in agriculture, medicine, and forestry. Now, if we look into the objectives of plant taxonomy provides a method for identification and communication. It also helps to identify all kinds of plants with their names, distinctions, distribution, habit, characteristics, and affinities. It tries to correlate the studies with scientific data contributed by various researchers in the field of botanical science. It gives an accumulated information and scientific knowledge of the world's plant resources. Taxonomy also aims to produce a coherent and universal system of classification and to demonstrate the evolutionary implications of plant diversity. One of the objectives of taxonomy is to provide single Latin scientific name for every group of plant in the world, both living and extinct, and to arrange plants in such a way as to give us an idea about the sequence of their evolution from simpler, earlier, and more primitive type to more complex, more recent, more advanced type in different periods of history. Taxonomy also helps in correct naming of the plants according to the International Code of Nomenclature. In this type, to every plant, a binomial name is given. The first name refers to its genus and the second name to its species. The name of the person or the author who observed and reported it is also denoted. It focuses on the documentation, which includes the preservation of living or fossil flora in herbarium. So now let us move on to history and development of plant taxonomy. The early history of development of botanical science is nothing but a history of development of plant taxonomy. Theophrastus, the Greek philosopher, scientist, placed his knowledge of plants on a scientific footing. In his inquiry into plants, he dealt with the plants at large and attempted to arrange the plants in several groups. He is therefore called father of botany. Pliny compiled a monumental work entitled Historia Naturalis, where he incorporated all information about plants he gathered. Dioscorides was a contemporary of Pliny and, like him, traveled a lot and gathered information about medicinal plants. He compiled his famous book, Materia Medica, where he described about 600 species of plants, mentioning their local name, giving their medicinal properties. Along with the description, he gave sketches which increased the value of book very much and gained much popularity. For a long period after this, there was no contribution in the study of plants worth mentioning. Later, Albert Magnus in the 13th century wrote De Vegetabilis, where the difference in the stem structure of dicotyledon and monocotyledons was shown, and the two groups were given the name tunicate and corticate. Otto Bruffels published his work Herbarium Vivae Iconis in 3 volumes, which was profusely illustrated with good figures. Andreas Zalpinio classified the plants on the character of their habit, trees, shrubs, and herbs, but also took into account the character of ovary, fruit, and seed. He became famous for his book De Plants in 16 volumes, the first of which contained his principles of classification. Gaspard Bohene has formulated the idea of genus and in many cases gave binary nomenclature to his plants. He also collected all names of plants published in different botanical works till his time and referred them as synonyms along with the names he used as correct ones. John Ray, an English naturalist, was the first to recognize 2 major types of flowering plants, namely the dicotyledons and monocotyledons. He also tried to group the plants into several families, which he called classes. He divided the plant kingdom first into 2 groups, namely herbae and arbors. The herbae were then divided into imperfectae and perfectae, the first of which included the cryptogams, and the second group, that is arbors, included most of the flowering plants. The perfectae were subdivided into dicotyledonae and monocotyledonae. His system of classification came out in his Historia Plantarum, of which several editions were published, and he revised and improved his system in later editions. Joseph Pitton Tonfort was a contemporary of John Ray and tried to work out a system of classification of flowering plants and was the first to give a clear concept of a genus, although Gaspard Bohene mentioned in his identifying the plants up to the species. Later, Carl Linnaeus, a Swedish naturalist, gave a new impetus to the study of plants. He himself was a collector of plants and also made arrangement for collecting plant specimens from different parts of the world by sending his students to countries far away. The discovery of numerous plants from all over the world led him to think about bringing an order into the existing chaos and set himself in grouping and classifying all the plants known till his time. He proposed a system of classification which was published in his Systema Naturae. In this system, he used the characters of stamens, that is the number and nature of stamens, to distinguish the 20 classes in which he divided the plant kingdom. He also used the number and nature of carpels to distinguish orders into subdivision of his classes. His system is an artificial system where very distantly related plants, that is plants belonging to widely distant natural groups, have been placed under one order of a class. As Linnaeus made use of morphological nature of stamens and carpels, mainly to classify the plant kingdom, this system is also called sexual system. Linnaeus published many botanical works. The species Plantarum contain an enumeration of all known plants to him till that date, accompanied by brief description of each species with the distribution and previous reference. In this work, he consistently used binary nomenclature for every species with a generic name followed by a specific epithet. In his Philosophia Botanica, he laid down some principles which later formed the basis of International Code of Botanical Nomenclature. Bernard de Jussy, who was in charge of royal gardens in France, tried to arrange the plants in his garden following the system of Linnaeus, and in doing so, modified the system to such an extent that it became altogether a new system of classification. He divided the plant kingdom into 15 classes and placed the classes under three major heads as Acotyledone, Monocotyledone, and Dicotyledone. De Candolle became famous not for his system classification, but his monumental work entitled Prodomus Systemis Naturalis Regni Vegetabilis, a book in 17 volumes in which he described all the genera and species of plants discovered up to that time. The descriptions are very elaborate and are accompanied by references to previous literature and to the area of distribution of each species. The best and most popular of natural systems of classification is that of Bentham and Hooker, the two British botanists who classified the Phanerogamia and gave an account of 202 natural orders under that group. This was published in the great monumental work Genera Plantarum, where elaborate descriptions of each and every genera is found. Keys are also provided for easy identifying the natural orders and genera. This book proved to be a very useful reference book, which, as well as the system of classification given here, became a very popular in Great Britain and other countries of the world, including America. Only the seed plants were taken up, and this was grouped or divided into three classes: Dicotyledone, Gymnospermae, and Monocotyledone. The dicotyledons were subdivided into three subclasses, that is Polypetalae, Gamopetalae, and Monoclinidae. The system of classification of Bentham and Hooker is the best of all natural systems. Description of natural orders and genera are very elaborate and accurate, being based on actual study of the specimens by the author. Therefore, for the purpose of identification of plants, this system is very helpful. Bentham and Hooker's system is not a phylogenetic system and is based on the idea of fixity of species. The position of gymnosperms in this system is very unsatisfactory, as it has been placed in between the dicots and monocots. Such anomaly is noted also in other cases in placing the natural orders under different series. In monocotyledons, inclusion of Iridaceae and Amygdalaceae in the same series with Scitaminae and Bromeliaceae is another example of such anomaly. In the use of terminology of different ranks of taxa, there is no uniformity. Thus, we find that under the subclasses Polypetalae and Gamopetalae of dicotyledons, the natural orders are placed under cohorts, which are again placed under series. But in subclasses Monoclinidae and in the monocotyledons, the natural orders are placed directly under the series. In gymnosperms, the three natural orders are placed under any series or cohort. Eichler, a botanist in Vienna, proposed a new system of classification of plant kingdom. Here he gave a more clear idea of lower groups of plants and also separated gymnosperms from the angiosperms, placing them in two taxa of equal ranks. This system is not considered as truly phylogenetic, but in one that it carries the idea of primitiveness and advancement in different groups in the plant kingdom. Adolf Engler, professor of botany, published in collaboration with Prantl a monumental work entitled Die Natur in Pflanzenfamilien, where all genera of the plants were arranged and described systematically. In doing so, they proposed a new system of classification for the whole plant kingdom. This system was based on some extent on the Eichler, but is a true phylogenetic system. In this work, they tried to use terminology for different ranks of taxa in a more scientific way. According to Engler, the most primitive type of flower is without perianth. The next higher type has one whorl. Then there are flowers with two whorls of perianth. Where the perianth is in the two whorls, they may be distinguishable into calyx or corolla or not. The gamopetalous condition is an advancement over polypetalous condition. Indefinite number of stamens and carpels is a primitive condition, while definite number is an advanced type. Superior ovary is considered as primitive condition from which inferior ovary has come through perigyny. Here, it is presumed that the dicots and monocots were derived separately from some extinct group of gymnosperms. Therefore, considering that the pandanales among the monocots and amentiferous dicots nearly approach the ancestral type, they are placed at the beginning of the two classes of angiospermy. The monocotyledone is placed before dicotyledone in this system. Engler's system was adopted by most botanists and was replaced by Bentham and Hooker's system in many countries in Europe and America. It was recognized by International Botanical Congress. This is a comprehensive system for all groups of plants and is a phylogenetic system. In case of dicotyledons, the amalgamation of Polypetalae and Monoclamidae into one group, Archiclamidae, is considered justifiable. Placing of Orchidaceae at the end of monocots and Compositae at the end of dicots is also considered proper, as these two families are most highly evolved in their respective classes. This system has, however, been criticized by many. The origin of monocots is now considered to be from a primitive group of dicots and not separately from the ancestral stock that gave rise to the dicots. It is the ranales from which the monocots have been derived. And this order is one of the most primitive among the dicotyledons, and the position assigned to it in Engler's system is not justified. The catkin-bearing families placed at the beginning of Archiclamidae are in reality highly advanced, as the simplicity of flowers is the result of reduction and not due to the primitiveness. In the case of monocotyledons, also the pandanales consist of the families which are rather recent in evolutionary line and not at all primitive. Charles Bessel, professor of botany at University of Nebraska, USA, also tried to work out phylogeny of the seed plants, and after several suggestions in that line, published in several papers, finally published his system titled The Phylogenetic Taxonomy of Flowering Plants. He divided the group Anthophyta or angiosperms into Alternifolia, that is monocotyledone, and Oppositifolia, that is dicotyledone, and each of these two classes were subdivided into Strobiloidea and Cotyloidea. Bessey considered that the dicotyledonous line is primitive in comparison to the monocotyledonous line, and among the dicots, plants with strobiloid type of flowers are very primitive. Therefore, he placed the ranales at the beginning of his system of classification, as has been done by Bentham and Hooker. Magnoliaceae of the order Ranales is the most primitive family, and Lactucaceae of the Asterales is the most advanced among dicots. He splits Compositae into several families. Lactucaceae is one of those new families. According to Bessey, the Anthophyta or the angiosperms originated from the Venetalian stock, and the alternifolia, that is the monocotyledone, was derived from the primitive group of Oppositifolia, that is dicotyledone. Rendell of British Museum of Natural History published his book, Classification of Flowering Plants, in 2 volumes. For arranging the families, he followed Engler's system in general with slight modification. As in Engler's system, monocotyledone was placed before the dicots. In monocots, the Pandanales is the first order, and dicotyledone starts with salicates. Hutchinson, a British botanist working in the Royal Botanical Garden, Kew, published a phylogenetic system for classifying the families of angiosperms in his book, The Families of Flowering Plants. The first volume containing the dicotyledons appeared in 1926 and the second volume in 1934. He divided his phyla Angiospermae into 2 subphyla, that is dicotyledone and monocotyledone. In the revised system, he abolished the groups Archiclamidae and Metaclamidae and placed the woody families under the division Lignosae and the herbaceous family under division Herbaceae. The monocotyledons originated, according to him, from the ranales and were subdivided by him into 3 subdivisions, that is Calciferae, Coroliferae, and Lumiflorae. Here also, those families are considered as primitive, which have usually hermaphrodite, that is bisexual, hypogynous flowers with numerous free and spirally arranged parts. Such families among the monocots are almost all aquatic, and therefore he concludes that monocotyledons were derived from primitive dicotyledons through an aquatic medium. The system of classification of monocots by Hutchinson appears to be more satisfactory than any other systems proposed by earlier workers on this line. The origin of monocots from primitive dicot is now considered a fact agreed upon by many modern taxonomists. In the case of dicots, however, dividing the group into 2 separate divisions from the beginning into Lignosae and Herbaceae seems to be arbitrary or illogical. Takatjan is a reputed paleobotanist working in Komarov Botanical Institute of Leningrad. He has also made a great contribution in the field of angiosperm taxonomy and proposed a system of classification of angiosperms. According to him, monocotyledone was derived from dicotyledone along nymphaeals through aquatic medium. Magnoliaceae is the most primitive among the dicotyledone, from which other orders of this class originated. He further modified this system and published the same in his book entitled Flowering Plants, Origin and Dispersal. He adopted a new terminology for the higher taxa, also according to the rule of nomenclature of plants. He therefore calls angiospermae as Magnoliphyta, the dicotyledone as Magnoliatae, and the monocotyledone as Liliaceae. Contrast of New York Botanical Garden drew out a scheme to show relation of orders of dicotyledon. He published a paper discussing the problem of classification of flowering plant, where he recognized 5 complexes among the dicotyledons. Of these 5 complexes, Rannellian complex is the most primitive, and from the complex, the other complexes of dicotyledone as well as the class monocotyledone have been derived. Finally, he published his book, Evolution and Classification of Flowering Plants, in 1968, where he classified dicots or Magnoliaceae into 6 subclasses. Finally, if we look into the summary, the aim of plant taxonomy is to classify the plant kingdom and to identify and name a plant and fix its rank in a recognized system of classification. This is done by using almost entirely the external morphological characters, that is gross morphology. Such taxonomy is called classical or orthodox taxonomy to distinguish it from the experimental taxonomy, where cytological or embryological evidences are also taken into consideration. The APG system, that is Angiosperm Phylogeny Group System of Plant Classification, is the first, now obsolete, version of a modern, mostly molecular-based system of plant taxonomy. Many different types of information can be and should be woven into classificatory system, and there is no obvious advantage in attaching overriding importance to any one type. So this is about the aim, scope, and history of taxonomy in brief. Thank you.